So learning target, use interval notation to specify where a function given graphically is increasing or decreasing. So let's first define what it means to be increasing on an interval. A function f is called increasing on an interval if f of a is less than f of b whenever a is less than b and a and b are in the interval. So whenever a is less than b, the output f of a is less than f of b. So that is from left to right, the function is getting bigger. The outputs are getting bigger. So stated simply, a function is increasing on an interval if its graph gets higher from left to right on the entire interval. Here's our first example. Let's look at this function. So from left to right, we're always worried about the domain values where it's getting bigger from left to right. So we see that over here at -2. So let me also say that this function is, the domain is restricted from -2 to 2. These types of questions, you can assume that what you see is the entire function. So from -2, we're down here. And as we go from left to right over this domain, we see that we're getting bigger, 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 bigger. And then right here at 0, the function starts to decrease. We start to slide down. So we're climbing, 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 climbing. And then at 0, we start to slide down. So it's getting bigger on the closed interval from -2 to 0. Therefore, the function f is increasing on the closed interval from -2 to 0, because that is where we are climbing in our domain. Okay. So now we want to define what it means to be decreasing on an interval. Okay, function f is called decreasing on an interval if f of a is greater than f of b whenever a is less than b and a and b are in the interval. That is, as you go from left to right, b is a bigger input than a, but its output is less than a. So we're getting smaller as we go from left to right. We're sliding down the graph. Stated simply, a function is decreasing on an interval if its graph gets lower from left to right on the entire interval. So looking at the same graph f of x from from the first example, we want to see where we're sliding down. Clearly, we're climbing, 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 climbing. Then at 0, we start to slide down all the way until we reach the end of our domain at 2. Therefore, we can conclude that our function f is decreasing on the closed interval from 0 to 2. One last example here. Indicate the intervals on which the function g is increasing and decreasing. So we examine this function and see that we're increasing. Here we're climbing, climbing, climbing. Then we hit this little peak here, and we just guesstimate kind of where that is. I want to say a -1.6. It's a little bigger than -1.5, so I'm going to say that's -1.6. And then we see from that point on we slide down until we bottom out right here. And again, just guessing, that's about 1.2. And then we start to climb up again. So we see that we're climbing there and climbing here. So we're climbing on the intervals. The function g is increasing on the intervals -2 to about -1.6, and then over here at about 1.2 to 2. Okay? And we're decreasing on the interval, this part where we're sliding down right here. So we said that was about -1.6, and this piece down here was about 1.2. So this whole area, the domain region in which our graph, we're sliding down the graph, -1.6 to 1.2. And one last thing before we end this video lesson, just quickly, a function f is called an increasing function if it is increasing over its entire domain. So if it's increasing over the entire domain, we call it an increasing function. And similarly, a function f is called a decreasing function if it is decreasing over its entire domain. And that is going to end this video lesson on increasing and decreasing functions. Thank you.